Now, to evaluate this definite integral, we start by integrating with respect to x, then we integrate with respect to y. So, if we integrate with respect to x, we have integral between 0 and 2. This gives us x squared over 2. So, put the values, that is 0 to 3y. Then we treat y as a constant, so that's y cubed plus 1 dy. This now gives us integral between 0 and 2. If we substitute values now, we are going to have 9y squared over 2. Then multiply by the square root of y cubed plus 1 dy. So we can write this as 3 over 2, integral between 0 and 2, 3y squared multiplied by y cubed plus 1 dy. Notice that if you differentiate what is inside this root, you are going to get 3y squared. So let us simplify the process by change of variable now. So say let u equals y cubed plus 1. Then if we differentiate u with respect to, so we differentiate, so we now go back to our integral. So we have 3 over 2 integral between 0 and 2. Now we replace 3y squared with the u dy. So the u dy, then times u raised to 1 over 2 dy. So dy cancels dy here. So we have 3 over 2 integral between 0 and 2 of u raised to 1 over 2 du. So if we integrate this, we are going to have 3 over 2. Then you can open this up. That will give us u raised to 3 over 2 divided by 3 over 2. And we are integrating, don't forget, between 0 and 2. But we cannot substitute 0 and 2 here, so we have to replace it with y, 3 over 2. And that will give us, of course, you can have now. So our u is y cubed plus 1. So y cubed plus 1 raised to 3 over 2 divided by 3 over 2. Then from 0 to 2. Now, you can now have 3 over 2, can cancel 3 over 2. So we have y cubed plus 1 from 0 to 2. Then this y cubed, we have raised to 3 over 2. So we substitute values. That gives us 9 raised to 3 over 2 minus 1. So if you evaluate that, you are going to have 27 minus 1, which gives us 26. So if we use our calculator, we are going to have 26. So that's the final answer.